In this video, I'd like to talk about the math question of the day for March 12th, 2023. And with this problem, we need to state the independent and dependent variables in the linear relationship, then find the rate of change for the situation. The cost of dinner is $70 for 5 teens and $112 for 8 teens. So to answer a question like this, you do need to have a solid understanding of Algebra 1, particularly linear equations, and this idea of rate of change. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, we know that we have a linear relationship, and it looks like we're dealing with the cost of dinner, some amount of money, and the number of teens. So we need to decide which is the independent and which is the dependent variable. Now, the dependent variable depends on the independent variable. It is affected by this choice. So in this case, it looks like the number of teens is affecting what the cost will be. So as the number of teens increases, it looks like that cost goes up. Our rate of change in this situation will be a positive number. So we can say that the number of teens, this is our independent variable. This is essentially what drives the dependent variable. And the cost is our dependent variable. This depends on how many teens there are. So if you're unsure which is which, you can always try it in reverse and ask if that would make sense. Would we use the cost as our independent variable? Would that drive the number of teens? And maybe in some scenarios that might make sense, but in this case, it doesn't. So in other words, the cost will not determine how many teens actually arrive. It's the other way around. The number of teens that arrive will determine the cost of the dinner. So now that we've decided which variables are which, we can determine what the rate of change is. And since we know this is a linear relationship, we are given two different data sets, or essentially two different coordinate points. We know that if we call this our x variable and the cost our y variable, then our first coordinate point would be 5 teens costing $70. And our second coordinate would be 8 teens costing $112. So essentially, these are 2 points on a line. And to find the rate of change, we effectively just need to find the slope of that line. Since with a linear relationship, the rate of change never changes. That rate of change is always constant. It's always going up or going down the same amount as the number of teens increase. And in this case, it's going up as the number of teens increase. So to find that rate of change, we just find the slope of the line. And if this was not linear, then this problem would be much more complicated. We might need the tools of calculus, or we might want to find just an average rate of change, which we can do using the tools of algebra. So the slope, remember, we can define in several different ways. This could be the rise divided by the run. That's usually how students will remember it, but it is the change in the y values. Let me rewrite that. This is the Greek letter delta. It means change in. So the change in the y values divided by the change in the x values. Or if we're looking at two specific coordinate points, let's say x1, y1, and x2, y2, then we can use the formula where the change in the y values, we just want to find the difference in the y values. We can do y2 minus y1, or we could write it the other way, y1 minus y2. It doesn't matter. We're just looking at their difference. But if we do y2 first in the numerator, then we have to do x2 first in the denominator. If we did y1 first, then we would do x1 first. So to find this slope, we just need to match up x1, y1, and x2 and y2. So let's say this is x2 and this is y2. Let's say this is x1 and y1. So if we plug in our numbers, we have 112 for y2 and y1 is 70. We divide this by x2, which is 8, and we subtract off x1, which is 5. Let me make a little bit of room here. So our slope then, we just compute this. We know in the denominator that that difference is going to be 3. And in this numerator, it takes 30 to get to 100, then 12 more, so that is 42. And 3 goes into 42 14 times. So this looks to be our rate of change, but we need to interpret it based on the units. Since remember that we're comparing the cost, that's our y value, and divided by our x value, our change in our x value, which is the number of teens, or we can just say teens. So what we found is the cost per teenager, where this is in dollars, and we would have one teenager on the bottom. So our rate of change is $14 per teenager. And with that information, we can predict what will happen if we increase the number of teenagers. If we look at 9 teenagers, then we take our $112 and add 14 to that. And so on. If we want to add, or if we want to have 10 teenagers, then we add 14 twice.